All right. Hi guys. This is Miss Cass. I'm going to be teaching you guys the Unit 5 summative review for Algebra 1 here. So you should have gotten a packet of some sort, and here we go. All right. So it says the first question we got, what is the formula for general exponential functions? All right. So our main formula, we've talked about it quite a few times now. We have y equals a times b to the power of x. Okay, we've also said that A represents the initial value. So that's whatever we start with, right? The y-intercept, any of those things. B is going to go ahead and represent either our growth factor, right? So something that's continuously growing, or our decay factor. And X represents our time, right? So 5 years, 2 months, some form of time. All right. Trying to make that a little clearer for you guys. Okay. So now it looks like we have two questions here. It says exponential growth, exponential decay, exponential growth. So is this factor in here greater than 1 or less than 1 when it's exponential growth? The answer to that is it's always greater than 1. So down here, we're going to do an example. I'm going to make up an equation of some sort. We'll say y equals 5 times 2 to the power of x. 2 is greater than 1, right? So this means it's doubling every time. So my initial's 5, so I could put a 5 right here, put a dot, and it is doubling every time. So it will shoot up. Okay, that's just a quick sketch of this. All right, over here we have exponential decay. So exponential decay, that's when the number in those parentheses is less than 1. All right, so these types of numbers include 3/4 or 0.5 or 0.02, right? Just because I give you a fraction like 5/4 here does not mean it is always less than 1, right? If you actually type this in a calculator, we get a decimal of 1.25. That is larger than 1. So just because we see a fraction doesn't necessarily mean it's less than 1. All right, so with that being said, we can write another equation here. Let's say y equals 50, parentheses, let's do a half to the power of x. So what does this mean, right? We are used to saying, oh, this is division of 2, but remember, when we write an exponential equation, we need it as a multiplier. So we're going to write 50, and we are just chopping it in half every time, right? So that means the next value, we would shoot down to 25, right? And we would go to 12.5 and so forth. So this would be exponential decay. It'll get really, really close to 0, but it won't touch 0. All right. Now it says convert the following percents into decimals. There are keywords in here like increase and decrease. So we have to remember that we have that 1 plus or minus r value, okay? These are all percentages. So the first thing that you will need to do whenever you see a percentage is instantly divide it by 100 in order to get it as a decimal. Okay, so that changes to 0.2 as a decimal. Now, if, again, remember, if something's increasing, it has to be greater than 1, right? And right now I'm saying my growth factor is 0.2. That doesn't make sense. It has to be larger than 1. So we have to put a 1 in front and do 1 plus, because it's increasing, 0.2. And 1 plus 0.2 is 1.2. Okay, let's go ahead and try this next one here. So we have 5%. So we take 5 and we divide it by 100. So we get 0.05. It's increasing. So we're going to do 1 plus 0.05, and we get 1.05 as our answer. The next one, it says decrease. Still have to convert that, divide it by 100. We get 0.17, but this time it's decreasing. So we're doing 1 minus our R value, which is 0.17. If we don't know how to do that, right, we take our calculator. So here's my calculator, and I type in 1 minus 0.17. I push enter, so my answer here is 0.83. Okay. Let's go ahead and move on to the next one. We have 2.3%. Now, just because we see it as a decimal percentage does not mean you don't convert it. You still have to convert it. So we still have to divide this by 100. So yet again, if you're stuck, you're confused, you take 2.3 in your calculator, you divide it by 100, and we get our decimal, right? So right next to this, I'm going to write 0.023. It is increasing, so that means I'm doing 1 plus this number, right? And if I add that in my calculator, I get 1.023. All right, now the very last one, again, some students will mess this one up, okay? So make sure you divide by 100 first. Whenever you see a decimal, it does not mean that's R. You have to divide this first by 100. So that gives us 0.005. And then it says increasing, so we're adding 1 to it, 1 plus 0.005. Our answer is 1.005. All right. Let's go ahead and flip the page and go to the next side. All right, here we go. Exponential properties, things that we need to know, okay? So quick recap. We can use some recaps up here. If we are multiplying, whenever we multiply, that means we add our exponents, okay? If we are dividing, division, well, think about it this way. Multiply goes with add, right? So division goes with subtraction, right? The other property you need to be aware of is if we have a power to a power. So that means if we have an exponent raised to another exponent, that is going to be a multiplication of our exponents, okay? So we multiply exponents. Okay, this should help us. So let's look at the first one. We have the same base, x to the 5th times x to the 4th. So that means we are going to go ahead and add 5 plus 4, right? Another way of visualizing this is there are 5 x's here, there are 4 x's here. So how many x's are there together? There are 9 in total. So we have x to the 9th. Over here, okay, we got to be careful on this. There are 2 ways of looking at it. The first one is noticing, oh, we're just adding again. Okay, I love that, right? 37 plus 0 is still 37. So our answer is going to be x 37th. Now, if you're like, but wait, anything to the 0 power is 1. That's fine too. That means you're going to do x to the 37th times this value is 1, right? And x to the 37th times 1 is still yet again x to the 37th. Okay, let's go ahead and look at C. C says b to the 19th divided by b to the 10th. So if we're doing division, we are subtracting those exponents, right? So we're doing 19 minus 10. And 19 minus 10 is 9. So b to the 9th is the correct answer for that one. All right. On D, again, multiplying by the same base means add the exponents. So 13 plus negative 3 is 10. 3 plus negative 3, again, we're adding exponents because we are doing multiplication here, right? So this would give us w to the power 3 plus negative 3, which equals w to the 0th power. Yes, you should write that down because we have learned anything to the power of 0 is always equal to 1. So 1 is our answer. That's all. All right, and then F. Now, hopefully you notice x has a power of 2, y has a power of 2, but it's all being raised to the power of 6. So this is the power to power property. So we have x squared to the power of 6. So that means we are multiplying. So 2 times 6 is 12, and 2 times 6 again is 12. So we got x to the 12th and y to the 12th. All right, now let's go ahead and dive into a little bit of what we call a word problem. Okay, there we go. So it says the following graph shows the relationship between how many hours of sleep, which represents T, students received and the number of wrong answers N on the test. So right away, looking at my graph, I know this is hours of sleep and these are wrong answers. So it looks like, just looking at the graph here, it looks like the more we sleep, right, the more hours of continuous sleep we get, the less likely we are to get incorrect answers on a test. That's what this graph is saying. So this first one says, how many wrong answers did students get initially? So keyword initially, when they didn't get any sleep. So this means 0 hours of sleep, right? And if the x-axis right now is representing hours of sleep, that means we're looking at when there were 0 hours of sleep, how many answers did they get wrong? Well, it looks like our answer's right here, 81. So we got 81 wrong answers. Okay, the next question says, what is the decay factor? So remember, decay means less than 1, okay? Gotta remember that. It means it's going to be B has to be less than 1. If we get anything larger than 1, we messed up somewhere in the problem. So a lot of students will look at the fact that, oh, it's counting by ones on my x-axis, right? It's going 0, 1, 2, which means I could somehow use this number and this number, right? Now the question is, okay, if I'm trying to find out the multiplier I need to go from 81 to 27, maybe I could try division of those two numbers. That's fine. So let's go ahead and do 81 divided by 27. You grab a calculator, you type it in, and you get 3. Now this is where we get stumped because our decay factor has to be less than 1, and right now we're saying it's 3. That means if I were to do 81 times 3, I should get 27. That doesn't make sense. What we're really saying right now is this is division of 3, right? We're saying, oh, you can divide by 3 and get this number. You can take 27 and divide by 3 and get 9. But when we do exponential equations, we don't do division. Okay, we do multiplication. So another way of doing this is recognizing that there's an invisible 1 underneath this 3. Which means all we have to do to get our multiplier is flip the fraction. Okay, so that means our decay factor is 1 over 3. We multiply by 1 over 3. This is just a multiplication sign. Okay, our multiplier is 1 over 3. Another way of doing this is just flip-flopping the fraction, right? If you recognize, oh, this is too big, then flip these numbers. You would do 27 divided by 81, and you get 0.333 on repeat. That is equivalent to 1/3, so either answer is going to be correct, okay? All right, the next one is writing the equation now. So writing the equation of the number of wrong answers, which represent n, depending on the hours of sleep. So instead of writing y equals, we need a new variable. So look at your y-axis. What are we saying y now is? We're saying it's n. So we're going to start with n equals. Well, what's the initial, right? That always goes first. The initial, you already answered it in question A. It's 81. So we write down 81. You could also see it here as the y-intercept. Then our decay factor, we found that in B, 1/3. And it's raised not to the power of x, but what was the x variable replaced as? T. So it's raised to the power of t. That is our equation. Okay, let's try number 2. Write an equation of this table. So first thing, you always want to write y equals the initial, right? We're following this as a guide. So our initial is A. What is the initial value in the table? Well, find the y-intercept. Right here, this is the y-intercept, right? So that means my initial value is 1/16. Now, question to ask yourself, is it growing or is it decaying? It does look like the numbers down here are getting larger, right? Which means we're multiplying by a number larger than 1. If fractions tend to confuse you, then ignore all this and go straight to here to here. Ask yourself, what number times 1 would give you 4? Think for a second. The answer to that would be times 4, right? 4 times 4 gives you 16. 16 times 4 gives you 64. So our common multiplier, our growth factor, is 4. So this is raised to the power of x, and that is our equation. Okay, let's go ahead to the next page now. Okay. A new species of mice is introduced to an island, and the number of mice is a function of time in T months since they were introduced. The number of mice is represented by this model of B of T equals 16 parentheses times 1.5 to the power of T. Is the population of mice increasing or decreasing over time? And how do you know? So what we need to look for is our growth factor, right? Or our decay factor, aka the number in these parentheses. And ask yourself, is 1.5 larger than 1 or less than 1? It's larger than 1. So if it's larger than 1, it's increasing. So it is increasing. And how do we know this? It's because the B value or the growth factor is larger than 1. And that's good. Now it says complete the table for months 0, 1, 2, 3, and 4. Well, I have T and I have B. T represents months. So I'm going to do 0, 1, 2, 3, 4. And now I got to fill this in, right? Well, remember, I have an equation. B of T equals 16 times 1.5 to the power of T. It was given to me. I'm just rewriting what was already up here, right? Like that's where I got it from. So all I have to do is plug these numbers in for T and I'll get the answer. So for 0, again, if I plug 0 in, anything to the 0 power here is 1. So this is all going to be 1 times 16, the initial value. 16 is first. Now you may want to grab your calculator and let's follow along. So we have 16 parentheses 1.5. And now you have to push this caret key over here. And we're going to raise it to the power of 1. We're replacing T with 1. Push enter, we get 24. Okay, now I'm going to do it again. 16 parentheses 1.5 to the power of 2 this time, right? Because I'm plugging in 2. So I'm just going to go ahead and change this to a 2. Push enter, I get 36. I'm going to do the same thing, but now replace 2 with 3. So now I'm going to go up here. Again, change this to a 3. You can retype it. That's fine. We get 54. And one more final step. Change that 3 to a 4. Push enter. We get 81. All right. So now it looks like every month we are getting these amount of mice, right? So we have to go ahead and now graph this. So this is months, right? And this y-axis here represents the mice. So we have our 1 month, 2 month, 3 month, 4 month, right? This goes all the way up to 4. And it looks like we have to go all the way up to 81, right? So if I count by ones, I'm definitely not going to hit 81. So what should I count by, right? Some people might say 4s, you might say 5s, right? The point is we have to be able to fit all the numbers onto the graph. So I'm going to count by 10s and skip every other line, and hopefully I do in fact get to 80. So let's find out. I have 10, skip 20, skip 30, skip 40, skip 50, 60, 70. It does look like I'm able to get up to 80, right? So I'm going to stop at 90 because 81 is my biggest. So now it's just estimating, right? So 0, 16. So 15 is in between, so 16 might be right about there, right? 124, so I find 1, I go up to where 24 might be, a little below 25. 36, so I'm going to go to 2, and I'm going to go all the way up to 36. Again, it's estimating roughly what 36 is. Now I have 54, so here's 3, up to 54, right about there. And I have 81, so a little above 81. Okay, I'm not going to connect the dots on this because we're saying each month, right? We didn't do half a month or a quarter of a month, okay? And we also can't have like fractions of mice. So I'm going to keep them as dots to keep them as whole numbers. All right, let's go ahead and look at number 4. When you fold a piece of paper in half, the visible area of the paper gets halved. The area in the function of the number of folds n is defined by a of n equals 93.5 times a half to the power of n. What does the 93.5 and the half in the equation tell us in context? So 93.5 represents the initial, right? And it's referring to the area. So it is the initial area of the piece of paper. 93.5 is the initial area of the piece of paper before putting it in halves, right? The half, remember this number here, you got to be careful about. In this case, it's going to be the same answer, right? But we have to remember that it's whatever was subtracted from 1, right? That's what you're taking away. So 1 minus a half in this case still equals a half, right? Because a half plus a half is 1. So this half right here is what's being taken, right? That's what we're folding every time. So the half represents taking away half the area. So a half means taking away half the area. Okay. All right, now we are going to fill in this table here. So again, it wants us to complete the table. We can go ahead and do the same numbers we did above with 0, 1, 2, 3, 4. Okay, N represents the folds and A represents the area. So N represents, we're going to fold it 0 times, right? If we fold it no times, what's the area of the paper? Well, it's the initial, right? So that one we should be able to get. Then we fold it 1 time. So that means, what are we doing? Well, chopping it in half, right? Our multiplier is a half. We're taking away half the paper every time you fold it. So our equation, we're just going to take it and we're going to plug 1 in as the exponent. So grab your calculator. We're going to do 93.5 parentheses. You can type in 1 divided by 2, right, to get a half, or you can type in 0.5 because they're the same thing. And we're going to raise it to the power of 1. And we get 46.75. All right, now we are going to, 1 second, let me pause the video. All right, sorry about that. I'm back. So now we got that number. All right, so here we go. We're going to plug in, we got the 93.5, a half to the power of 2 this time, right? Raising to the power of 2. So again, changing that in my calculator, scrolling over to where 2 is and pushing enter. I get 23 let's just round it to 4. Sorry, I'm going to pause the video so you don't have to hear this. Sorry for that after school. So we got 23.4. Okay, now let's go over and put a 3 in, right? Because we're going to plug 3 in this time. Push enter. We have 11.68 or 11.7. And then we can do this again. And 4, enter, we have 5.8, okay? So now we have to graph this. So we have our folds that represent N, right? And this represents A. So we can count by 1s down here because we're just folding it. But we need to go all the way up to 93. So it looks like when I was counting by 10s up here, I'm going to be able to get 100. So I'm going to go ahead and count by 10s again. So skipping every other line, I'm going to count by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and then we're at 100. Okay. So to start this off at 0, I have to go up to 93.5. So 93.5 might be right about there. Just making some good estimates, right? And then we got 147 roughly, right? So 1, go up to where 47 might be-ish. Yeah, and then we got 223. So 2, find where 23 is, might be like right about there. And then we got 311 there, and then we got 45.8, like right there. Okay, now again, I'm not connecting the dots because I'm not doing like a half a fold or anything like that, right? They're all whole number folds. So I don't want to connect the dots to say that there's any other points, right? Okay, let's go ahead and flip it. Next problem here, we got consider the graph f of x, the corresponding table. So it looks like we have this point here that's put in our table. We have this point here in our table, and we have our last point, which is in our table. Does the graph show exponential growth or decay? Well, if we're looking at our y values, okay, these are our y values right here. Or you can look here, it goes 3, 6, 12, right? 3, 6, 12. So what could be our multiplier? So that way we would go to 3 to 6 to 12. And now notice I didn't say what's our addition number, right? Because yes, it could be going up by a number addition, but it says exponential, which means it's going to be a multiplier. So 3 times what is 6? If you're not sure, just do 6 divided by 3. What do you get? Oh, you get 2, right? So this is multiplication of 2. And you can check it. Type in your calculator, 3 times 2, 6. 6 times 2, 12. You get the answer. So 2 is our growth factor, which means it's larger than 1, which means it is growth. Another way of seeing this, right, is just noticing, hey, from left to right, because that's how you read, right? You read left to right. From reading left to right, our graph, it goes up. So it must be growth. The y-intercept. All right, what is the y-intercept? Well, here's my y-axis, right? So what's the point that goes through the y-axis? Oh, right here, 0, 3. So 0, 3 is my y-intercept. And then it wants to know, what is the factor? Well, it's a growth factor, right? And we found it already. It's 2. So the growth factor is 2. Now it says, write the equation. All right, we got f of x equals, or you can say y equals. It's okay, either way. The initial. Well, the initial is your y-intercept. So 3. Parentheses, your growth factor, which is 2. And it's raised to the power of x. Okay. Now, D says, using our equation, right, we have to figure out what is the value when x is negative 1. So all it's asking us to do here is replace x with negative 1. So 3 parentheses 2 to the power of negative 1, what does that equal? So this is where you take your calculator if you don't know, right? You type in 3 parentheses 2, close the parenthesis, raise the exponent, and then make sure you push the negative key and a 1. And then push enter. Looks like we get 1.5. So that means our answer is 1.5. All right, E. What is the equation of the function g of x graphed below? So g of x, this does not look like growth anymore, right? Because it's going from left to right, it's going down. Okay, so that means we're doing some type of multiplication yet again, right? It's a multiplier. We're multiplying. We're not dividing, we're multiplying. Okay, of how we go from 8 to 4 to 2. Well, the first thing that comes to mind is, I know 8 divided by 2 is 4. I know 4 divided by 2 is 2. So some people might do 8 divided by 4, and they're like, oh yeah, that's 2. But remember, the growth factor, decay factor, it can't be 2 because it's decaying. It has to be less than 1. So again, remember that if we're decaying, we can flip our fraction. So we're really multiplying by a half, or you can say that as 0.5, right? And if you're not sure, right, like just double check. Take 8, multiply it by 0.5, we should get 4. Multiply that by 0.5, we should get 2, right? So what is the equation? Well, I found my factor. So I have g of x equals, because it says g of x, our initial, which is right here, our y-intercept. There's 2 spots to see it. We have 8. Parentheses, our decay factor of a half. So the power of x. All right. Number 6, we're almost done. We got 3 more problems, I believe, left. Yep. Okay, so Tyler bought a used car on his 16th birthday for $4,000. Wow, that's a good deal. His car is depreciated at a rate. So we have to remember what the word depreciates means, okay? Depreciate means it goes down. It's a losing value. And that should make sense in the real world. If you have a car, it's going to lose value, right? If I was trying to sell a 2010 Jeep versus a 2025 Jeep, it's going to be way cheaper. Okay. So it says that it depreciates at a rate of 2.6% semi-annually, and the initial cost was $4,000. Find how much he can sell his car for in 6 years. So we're going to find out the value of his car and what it's worth in 6 years. And we have this nice compound equation already written for us. So A is our initial. Our initial amount of a car is 4,000. Okay. Our R value, that's the rate, right? We need to figure out what R is. So remember, if I give you a percentage, always divide it by 100. Always. So the percent, we have 2.6. We divide that by 100, we should get 0.026. So this is 0.026, or you can write it as 0.026, however you want to write it. It's the same thing. N is what it's it's what it's compounded by. So in this case, it says semi-annually. So semi-annually means twice a year. So N is 2. And then it says T. Well, T is what we're trying to find, right? Like the amount of time it's going to take. He wants to know the time in 6 years. So 6 is our time. Now we have an equation, and we're going to plug these numbers in. So we have y equals A, our initial 4,000. There's a 1 right here, so we have to put a 1. And remember the word depreciates. Are we adding or are we subtracting? If it's losing value, we are subtracting, minus. Our R value, 0.026. And it's over our N value. And our N value in this case is 2. Now I'm running out of space for this, but we still need an exponent, right? Our exponent is N times T. So N2 times 6. So I'm going to put in parentheses here, 2 times 6. Now, some of you might be like, oh, well, I know 2 times 6. That's 12. That's awesome. So you can go ahead and just rewrite this as 12, right? You can just put the exponent to be 12 if you know that. Now you're going to grab your calculator and you're going to type it in. Now, if you decide to type it in the first way, you can, but you have to make sure your exponent is in parentheses. If you don't do that, you're going to get the wrong answer every single time. And then your teacher's going to draw a sad face because you didn't listen in this video about using parentheses. So you're going to use parentheses, raise it, and now put in parentheses to the power of 2 times 6. Parenthesis, 2 times 6, parenthesis, enter. This is our answer right here. So we have 3,418.74. How did I get that 4? Well, remember the third decimal here is an 8. That's larger than 5. So it's going to push this number up 1. So he can sell his car for $3,418.74. That's an 8. All right, next problem. We have a savings account, okay? Savings account is earning money, So that means increasing, right? 5% interest each year, and it's compounded quarterly. A person invests $750 and makes no further deposits or withdrawals. So now first, let's figure out A, N, R, and T. A is our initial. So our initial amount was $750. N is what it's compounded by. It says compounded quarterly. Quarterly is 4. 4 times a year, quarterly. R is not 5. Do not put a 5 here. You first have to divide by 100. So 5 divided by 100 is 0.05. And then T. Right now, in this current problem that we're given, do they tell us the time? They don't. They don't say how many years, anything. Okay, they just said each year. That, right? Like that, it's not telling us how many years. So right now, we don't know T. So I'm going to leave that blank. And then it says write an equation. So I have all the pieces except for T. So I'm going to write the equation except for T. So I have y equals 750, parenthesis 1. I'm earning money, right? Earning. So I'm going to add 0.05 because that's my R value, and I have to divide it by N. N is 4. And I'm raising it all to the power of 4 times T. And again, I don't know T, so I'm just going to write 4 times T. Or you can write 4T. All right, now B, it says, what is the balance in the account after 2 years? So now they're giving me the time. The time is 2. So now all I have to do is use my equation, replace 2 with T, right? So I'll have Y equals 750, parenthesis 1 plus 0.05 divided by 4 to the power of 4 times 2. Okay, so I'm going to grab my calculator and I will demo how to show this again in my calculator. I have 750, parenthesis 1, plus 0.05 divided by 4, close the parenthesis, raise it to the power of, don't forget your parentheses around your exponent here, 4 times 2, parenthesis, enter. Okay, we got 828 $36. Okay, I did not round up the 6 because the 4 is smaller than 5, so it just stays. All right, here we go. Last problem. The following function models compound interest on a college loan that earns interest annually. Okay, so this is our equation here. What is the interest rate on this loan? So I can see right now that this is my growth factor. Okay, and I know that I get this number by doing 1 plus something to get that. Well, think of it as money, right? I have $1.04. I have the dollar. What did I add to the dollar to get the 4 cents? Oh, 4 cents, right? So the blank here is 0.04. This is your R value. If you guys remember doing the 1 plus R, this is R right here. So what is the interest rate? What is the percentage? Well, if I know R, then instead of dividing R by 100, right? Because this isn't the percent, I'm trying to get the percent. I'm actually going to do the opposite, and I'm going to multiply by 100. If I multiply this by 100, I'll get 4%. The answer here is 4%. That is my interest rate. What is the initial loan on the amount? Or sorry, what's the initial loan amount? Okay, well, we know A is always the initial amount. So that should be super fast. 16,000 is the answer. If the student plans to pay this off in 5 years, how much will they owe? They're telling us 5 is replacing T, right? When T equals 5, how much money is there going to be? So I have an equation. I am just going to replace T with the number 5. Grab my calculator and type in my numbers. So 16,000, parenthesis, 1.04, parenthesis to the power of 5. Okay, so I got $19,466.45. Again, why did I round? The third decimal is larger than 5, so it rounds it up. So they will owe $19,466.45. All right, that is the end of this video of all of the notes from our Unit 5 summative review. Please make sure if you didn't understand anything, you rewatch it, right? Make sure that you're studying, retry all these problems. If you have a blank packet, I know I give out blank extra packets. Maybe you can ask your teacher for a blank extra packet if you ever need it in the future. But I hope this video helped you all, and good luck on your test. Bye, guys.